Good morning. I am Paolo Perillo, Project Manager at Ticass, and this video lesson is about the Kharon system and how we use it in TRINEFLEX. Kharon tool objectives in TRINEFLEX are provide TRINEFLEX with an holistic solution for data storage, processing and security, to deploy in cloud in compliance with legal requirements for local data storage of the use cases, to enable data management of data collected from the field, their storage, their dispatching, and provide access control capabilities to datasets and pilot infos, following the cybersecurity practice. Enable acquisition and transformation with widely used standards such as MQTT, make data and info available and accessible to other platform modules and project partners through specific APIs or through international data spaces. Ticass efforts on this kind of solutions date back to 2013, and Kharon was introduced in 2019 to evolve pre-existing solutions with the objective to satisfy the need to gather and manage big data in IoT projects. As you can see, the key points for its development are broadly matching the TRINEFLEX need. For those of you who are not familiar with the time data series, let me explain what is the meaning of time data series. Time data series are associated to a given device at a given time. Very simple concept in itself, but its management becomes very, very complex when you have thousands of devices, billions of records. As said, each record in a time data series is associated to a device and its data series, including the metadata such as data type, retention time, structure, etc. The Kharon tool therefore sits on the edge between two worlds: the field, to gather data from the field devices, and the cloud for services and applications, to allow users to benefit from data collected from the field and further post-processing. Application and services, on the other hand, are considered clients operated in trusted environments and capable of managing more sophisticated security and authorization schemes, enabling them to access a wider range of functions. Depending on the data to be collected, device type, data series type, each use case built up its data flow architecture to secure flawless data transmission to Kharon. In the picture is represented as an example the ESAMUR use case data flow architecture and the communication layout that was deployed. In this slide are represented the data flow architectures deployed in the other use cases. You can see every use case adopted slightly different strategies according to volumes, device types, own architecture. Let me provide you with some information on the architecture. Kharon is designed in blocks with a graphical user interface, a registry, an MQTT HTTPS gateway, a streaming platform based on Apache Kafka, a storage container based on Apache Cassandra, and a retrieval platform. All definitions and data for a given client or project are contained in a tenant. Each tenant segregates its contents from the others. In TRINEFLEX, each use case is provided with its own tenant, which is represented in the square, in the red square. Kharon has some distinctive security features designed to provide security to the info and to the user, to protect their data and allow access only to authorized users. And now let's take a look at the tool. This is the logon to Kharon, which is a standard sign-in design with the credential provided by the administration. This is the Kharon homepage with the menu bar on the left and the possibility to manage different widgets: device type, data series, rules, devices, applications, and gateway. The device type page offers the overview of devices types, and their attributes. This is a screenshot taken from the TRINEFLEX administration panel, and as you can see, it shows device ID, device description, device type, gateway, and the creation and update status. Each use case then has different setups. In this slide are displayed the use case device types, which differ according to the variables to be collected and the number and type of devices. Same is for each use cases. Same with data series. This is an example of the ESAMUR pilot. And as for the devices, also for data series, each use case has different setups. The tool allows the possibility to make changes, to display and edit data, to change, and last but not least, allows management of REST API for those who need to post-process the data that have been gathered into the tool. Conclusion. Let me provide you with some info on the versioning and capabilities. The current Kharon major version is version 4. For TRINEFLEX, it was load tested, demonstrating the capability to manage over 10,000 messages per second from thousands of connected devices. Kharon version 4 achieved 100% uptime over the last year, managing about 1.3 million messages per day, with a system load about 10–15% of the total. In conclusion, I want to thank you for the interest in this tool. Thank you.